We often believe that to go faster, to deliver more value quicker, you have to sacrifice quality. To deliver high quality products, you have to go slower. But why do people think this? Imagine a team that has a high bar for quality and can deliver at an acceptable level of speed. Now, let's say there's some pressure from somewhere in the organization to see if the team can deliver a little faster, just for a little while. So the people in the team work a little harder. And at first, things are pretty good. Maybe they work a little longer, through their lunch breaks, stay a little later, start a little earlier, and they get faster. And the quality drops by an acceptable level, so no one really notices and everyone's pretty happy. Maybe this fictional team is congratulated for working harder, going the extra mile, pulling out all the stops, moving a little quicker. Maybe some team members decide to push a little harder, answer those requests for features out of hours, maybe offer some advice when they're on holiday. Maybe some more requests come in, from the organization to see if the team can fill another request, just the one. It'll only take a minute, a minor tweak to the UI or feature. This time though, they take a teeny little short. Maybe they don't spend as much time thinking about what the risk could be by making those changes. Maybe they don't create a ticket and run it through the team's board like they usually would. Maybe they don't pair on the work with another developer. Maybe they don't chat with their testers on the team, see what they think about it. Maybe they skip writing the test to get it out quicker. Nothing malicious like pushing code directly to production by bypassing the build process. And the team go a little faster. But this time the quality drops too, which a few people notice. Maybe your testers who raise a few more bugs. But it's not clear if it's the fact that you're working hard or that the work is actually hard to do. And because of that ambiguity in the situation, is it working hard or the work's hard to do? Some people decide to double down and see if they can go even faster. It's what everyone wants, the business, the users, even the team. Maybe they take some even more shortcuts. Skip a couple of meetings here and there. Just sit on your laptop, no one will notice. Maybe you don't go on that training course on leadership or touring. Maybe you skim on working with more junior members of the team. You show them next time. Maybe you brush that bug in production under the carpet. It's fixed now. No one needs to worry about that. And the team goes even faster. But this time, the quality levels have really dropped. So much so that users are starting to complain more regularly. Maybe even your head of department's being tweeted at directly about bugs. It's finally dropped to an unacceptable level of quality. And we've now sacrificed speed for quality. So how do we close the quality gap? Well, because of that ambiguity, was it because we're working too hard or was it because the work was hard to do? The obvious solution here is more testing, by testing harder. If you can catch the bugs before they go into production, we can surely keep the speed while improving the quality. So let's add a waiting for test column. Every ticket worked on the team must now go through the testers. But the testers can't test everything. So let's help them out by automating more of the testing they do. Now, this causes quite a few problems, but the main one for this scenario is that it's pushing testing towards the end of the process. The problem is that as the quality goes up, the speed starts to drop, and as testing starts to become the team's new bottleneck to delivery. And if you're interested in learning more about why pushing testing towards the end can be a problem, then check out one of my past talks. So if you're wondering why we see speed and quality as opposite ends of the spectrums, especially if the best way to increase speed is by working harder, but to increase the quality, you must do more testing. But is there a way we can have both? Hello everyone, and welcome to my talk. Don't test hard, test smart. My name is Jitesh Gosai, and I work as a principal tester, and I've been working in the software industry for the last 20 years. And over that time, I've worked across the software industry, from large enterprise banks to small 10-person startups, and more recently to a well-known UK-based media streaming company with millions of daily users. And what I help organizations do is create a culture of quality, which is one where we don't inspect for quality by testing the things at the end of the development lifecycle, but one which looks to build quality in at every level that we work, from the products that we build to the processes that we use to build them, and into the very interactions between the people who use the processes to build the products. And one of the ways in which I do this is by spending time with teams and helping them understand what we are doing, how we are doing it, and how we can do it better. I've recently started my own quality engineering newsletter too, where you can learn more about how we can all create cultures of quality and how we can all test a little smarter. And you can also find me on social media too, such as on Twitter and LinkedIn. And one of the many conversations that I often get into in my role is, what does testing hard and test smart mean? And what does it have to do with speed and quality? Well, testing hard is all about how we can do more testing in less time, and usually results in people working hard and tends to view things as speed or quality. Whereas testing smart is all about how we can improve our capability to do the testing, and is about working smarter and views things as speed and quality. So, how do we test smarter? Well, let's get back to our little hypothetical scenario. This time, instead of the pressure to work harder, the ask is to work smarter. How? By not directly focusing on speed or quality, but our capability to do the work. And specifically to improve it using experimentation, to encourage trying things out and seeing what does and doesn't work. Now, these things can sometimes get a little derailed. When you start to work on improving your capability, there's a good chance that instability can be introduced into your existing process. And your speed, quality, or both, as in this case, can drop. Now, this is usually where the derailing happens, as people panic. If you're trying to improve your capability and then your speed or quality drops, it can seem counterintuitive. You're trying to get better, not worse. Now, what happens here is that people panic, and it leads people to stopping the improvement process and going back to the existing process. And suggestions are made, maybe now's not the right time, maybe next quarter will be better. What I would say here is that you need to improve your ability to learn from failure. And that rather than only trying to mitigate failures, we should embrace some level of instability and learn from it. But for our teams to be able to truly embrace improving their capability through experimentation and learning from failure, they need the support of their leadership team to give them the time, the space, and the reassurance that they understand some instability is inherent with the experimentation, and that we as a leadership team believe that the engineering team can figure out the best way forward, incorporating that learning back into their capability to do the work. And with time, they'll begin to see that not only have they improved their capability to do the work, but they've also stabilized their quality to levels like better than before, but also they've improved their speed too. And it's what I mean by testing smart. And they've done all this sustainably without resorting to testing hard. Now, these two models of working harder and working smarter are taken from a research paper called "Nobody Gets Credit for Fixing Problems That Never Happen," which appeared in the 2001 California Management Business Review. Now, to be fair, they were focused on manufacturing, but the concepts of working harder and working smarter very easily translate across to building software and other types of what we call knowledge work. Now, an interesting aspect of working harder and working smarter models is that they are self-reinforcing and can become the default ways of working in your teams. The reason for this is that once people start working harder, their capability to do the work begins to be eroded, and therefore the only way to continue performing is to work harder still. While if they adopted the working smarter model and they successfully improve their capability to perform, then they'd have even more time devoted to capability improvement process, which can use to reinforce that behavior. It just keeps going around in a virtuous cycle. Now, the working harder loop isn't all bad. In short bursts, it can be helpful for handling those unpredictable, unplanned, and urgent issues. But if those urgent issues are happening quite regularly, then there's a good chance that that team falls into the trap of always working harder. The working smarter loop isn't all good either, because the more complex your work is, and building software tends to be a complex task, the longer those capability improvement processes are likely to take. The failure rate is likely to be higher, and the overall improvement could be harder to measure. There is another aspect we need to consider too, and that is, what does speed and quality mean? What you tend to find is our definitions of speed and quality are quite open to interpretation. What is fast for me might be slow to you, and what is a low quality bar for me might be a high one for you. This means measuring speed and quality can be quite difficult, and therefore knowing if you're working hard or working smart even more so. Luckily for us, a lot of research has been done into this already, and particularly by Dora, or the DevOps Research and Assessment Program, which has spent the last 8 years researching what practices and capabilities drive high performance in software teams. Now, if you haven't heard or read in these papers, I highly recommend you do so, and I'll link out to these again at the end, as I'm only focusing on a small, but from my perspective, significant part of it. which is the 4 key measures that I've identified that are good proxy measures of speed and quality. Now, the terminology used is a little different. Instead of speed, they use throughput, which they recommend measuring delivery or change lead time and deployment frequency. And instead of quality, they focus on stability of the system deployed, which they recommend recording your mean time to recovery for failure and change failure rate. But these are not the most self-explanatory, so I like to think of them as questions instead. For lead time, how long does it take you to go from code commit to running in production? For deployment frequency, how often do you deploy small batches of code to production? Why both these measures and not just one? Well, lead time tells you how quickly you can make a change and get it through your build process, whereas deployment frequency tells you how often you deploy. For mean time to recovery, how long does it take you to restore degraded end-user service? And degraded end-user service is anything that stops your users from carrying out a task and you have to remedy that problem. Now, the great thing about this measure is that it embraces failure and says, we know issues will occur. So how quickly can you resolve those issues and get your system up and running for your users? And finally, change failure rate. What percentage of deployment results in degraded end-user service? While we want to embrace failure, we also want to be doing our best to make sure we're not intentionally causing more problems by deploying too frequently. So this lets you know if you're regularly pushing out a dud release for users. So how do these 4 key metrics relate into working harder and working smarter? Well, working harder will be focusing on throughput and stability as separate things to achieve and sees them as alternatives. Alternatively, working smarter will be looking at these measures in a much more holistic way and trying to better understand how you can perform as a team and trying to get to the point where you're going faster and producing a quality release, but in a sustainable way. Now, as a team, by agreeing to use these measures and the same terminology, it allows you to remove some of the ambiguity I mentioned earlier about what fast means and what does quality mean. Now, these measures are by no means perfect, but what they allow us to do is to reduce some of that uncertainty in the way we work, which means we can make much more informed decisions based on data rather than just intuition or expert opinion alone. What this means for software teams is that the conversations are much more focused towards what is working smarter and means seeing what we can be done to improve their capability to do the work. Now, we can still use working harder, but for when it's really needed. And as always, defaulting back to working smarter and looking to learn why you need to work harder in the first place. You also now have a set of measures that tell you how successful you're being at improving your ways of working and the system you're building and maintaining. So how do we not test hard and test smart instead? By taking the time to understand why we think we must work harder, we can start to see ways towards how we can work smarter. And maybe instead of calling it testing or working smarter, let's just call it what it is: continuous improvement. So thank you for listening to me today. Here are some further reading and links to papers, reports, and techniques I referenced. You can also find these notes and more in this link on the right. And if you'd like to learn more about how to test smarter, then check out my quality engineering newsletter. Thank you.